here's an introduction to basic quadratic functions. The first function we're going to look at is y equals x squared. Now if I want to graph y equals x squared, I can make myself a table of values. So I'm going to pick some values for x. I'm going to pick 0, 1, -1, 2, -2, 3, and -3. And I'm going to substitute those values into my equation and calculate a corresponding value for y. So if I go 0 squared, my y value is going to be 0. 1 squared, my y value is going to be 1. -1 squared is 1. And so on until I've filled out all the points in my table. Now I'm going to graph this on my axis. So 0, 0, over 1 up 1, over 2 up 4, over 3 up 9. And I'm going to do the same thing on the other side. -1, 1, -2, 4, -3, 9, because these points correspond to the points that I calculated into my table of values. So this is the shape of a quadratic. This is the basic quadratic shape, and we call this shape a parabola. Now all parabolas have a series of properties that we can talk about. So the first property that you can determine from every parabola is a vertex. So if I've got my y equals x squared parabola drawn on this graph, the vertex is always the point where the parabola changes direction, or it's always the bottom of your parabola, or the top of your parabola is going the other way. So this point right here is the vertex. In this case, my vertex is at the coordinate point 0, 0. The next property that we're going to look at is the axis of symmetry. Now the axis of symmetry is the line where if I fold my parabola in half, it's going to look exactly the same on either side. So it's the line where the parabola can be folded in half. And it's always an x equals line. So in this case, we look at where our line goes through in the x-axis. Our line goes through at 0, so the axis line, or the equation of the axis of symmetry, is x equals 0. The next thing we can look at is whether our graph has a minimum or a maximum. My graph goes down to a line and then goes back up. So for this graph, I have a minimum value. And my minimum is at 0, 0. I would have a maximum if my graph was going in the other direction, if it was going up to a value and then coming back down. The next property is the y and x intercepts. So the x-intercepts are where it crosses the x-axis. And in this case, it crosses the x-axis at 0, 0. The y-intercepts are where it crosses the y-axis. And again, for this graph, that's going to be at 0, 0. My final two properties that I need to look at are domain and range. Now, domain of the graph is all possible x values. For a parabola, all possible x values, because this graph goes on in both directions forever and ever and ever, we write as x is the set of all real numbers. The range is all possible y values. And the range in this example, because my graph on the y-axis goes down to 0 and then goes back up and never goes below 0, all of my y values must be greater than or equal to 0. The last thing we're going to look at is how to change a quadratic function. Now you have two different forms that we write quadratic functions in. One is vertex form, and we call it vertex form because we can identify the vertex from the equation. The other one is standard form, and this form has no brackets and is generally more useful for substituting into a graphing calculator. If I want to go from vertex form to standard form, I can just do some math and expand my brackets. So x minus 1 squared is the same as x minus 1 times x minus 1. And then I can add the 3 on. Now I'm going to use the distributive property and multiply everything in the first bracket by everything in the second bracket. I get x squared minus 1x minus 1x plus 1 plus 3. And when I collect my like terms, you can see that that gives me the standard form of the equation. So it is possible to go from vertex form and convert your equation until you've got it into standard form.